The goal for this problem is to rotate the matrix 90 degrees clockwise, which is to transfer from the left one to the right one. Let's pick up some points to see how this is made. For 2, it goes from 2 to 10, 10 to 24, 24 to 16, and 16 to 2. For 7, it will go to 9, 19, 17, and 7. If we know the relationship of these 4 points, then we know the answer. However, these points are neither sitting on the same row nor on the same column, and they're not even symmetric. This makes our life really hard. Instead of trying to figure out the answer by looking at 4 together, what if we only look at 1 point and see what can get from there? Take 2, for example. If we make it symmetric about this middle horizontal axis, we will get 22. If it's vertically, we get 4. And diagonally, it's 6. You might have noticed these points are not the final answer, but if we go one step further, they will be the answer. Let's call these points to be point 1, point 2, point 3, and point 4. From 1 to 2, we'll do the symmetric with horizontal axis first and then diagonal. From 1 to 3, it's going to be horizontal first and then vertical. From 1 to 4, it's diagonal and then horizontal. Let's take another example to see if this rule is correct. Say 7. Horizontal and diagonal will be 9, which is correct. Horizontal and then vertical is 19, correct. Diagonal and horizontal is 17, which is also correct. Because of timing, I won't give more examples, but you can play around with it. Okay, this means our rule is correct. Now it's time to write out the relationship using equation. Because this is a square, the length and the width are both n. In the first case, which is horizontal, x plus x prime equals n minus 1, so the coordinate is n minus 1 minus x, y. In the second case, y plus y prime equals n minus 1. This gives us x, n minus 1 minus x. And the last case is yx. Having these equations, let's write those points out. From 1 to 2, we will first have n minus x minus 1y, and then y and minus x minus 1. The other points are basically the same, just plug into the equations and do the math. Here's what we finally get. Point 3 is n minus x minus 1, n minus y minus 1. Point 4 is n minus y minus 1x. After knowing the relationship, now we want to know which part of the points should be selected. Since each point is associated with 3 different points, and only a quarter of points are chosen. For the first line, it's 1 to 4, and the second line is 7 to 8, while the third line is only 13. Because 13 is only itself, no matter how it's rotated, it's still itself, so we can basically ignore it. So the leftmost points are following this diagonal line and stop in the middle. Where should the rightmost point sit? It should sit left to the points, which can be affected by the leftmost point. So what does that mean? For example, the first line can only go to 5. The first line cannot go to 5, and the second line cannot go to 9. So which is basically where the left point gets projected by this vertical axis. If we write out the loop, I starts from 0 to n divided by 2, j starts from I, and ends up at n minus I minus 1. So at this point, I've finished all the analysis. Let's move on to the code. So for this point, if you know how all the thinking process, it's very easy to write out the code. We have this for two for loops, and have a temp int to records a value and substitute like all this value one by one, and That's all.